All right, guys, welcome back. We are still in BGP. We're going to be looking at doing some more really kind of route manipulation, what we call traffic engineering with BGP. And in this case, we're going to be looking at traffic engineering with communities. I kind of shortened this lesson a little bit because as I was going through the notes, I thought, you know, this is not one of those things that you would typically see on the CCIE lab. And I doubt there's probably really just a little likelihood that you would see anything like this on the lab. But I did want to add this as part of our discussion because I think it's a pretty interesting topic, especially when it comes to routing over the internet and the decision of routing over the internet. So we're going to talk about it. We won't spend too much time on it. We will spend much more time on our aggregation discussion, which will probably happen on Thursday. But we're going to focus our attention primarily on this little traffic engineering with communities discussion. So we're going to take a look at traffic engineering using these BGP communities, which communities actually provide a lot of extensibility within BGP, and typically we'll see them quite a bit in the use of layer 3 MPLS VPNs, but we can actually use these communities to actually kind of influence path selection. There's an RFC called RFC 1998 that actually allows us or defines this concept of applying BGP communities to facilitate multi-homed routing. So we'll come back to communities a little bit more detail later. We're going to talk about standard and extended communities. We're going to talk about, you know, what are well-known communities like the community no export or no advertise or local AS. But in this case, we're just really talking about making use of a community as a tag so that we can use that tag for traffic engineering based on signaling that we're going to send to a service provider. All right. But this RFC really kind of defines how this functionality works and what I would do with this functionality in order to influence traffic selection. It says that we can use communities as an attribute of the application so that we can simplify the implementation and configuration of routing policies in a multi-homed service provider environment to the internet. And it shows specifically how the community-based configuration, specifically in the community attribute, can be used to replace something like an AS-based customization of the BGP local preference attribute, for example. So it says here, this memo provides information for the internet community. The document presents an application of the BGP community attribute in simplifying the implementation and configuration of routing policies in a multi-provider internet. It shows how the community-based configuration can be used to replace the AS-based customization of the local preference attribute, a common method used today. All right. So this is kind of a paradigm shift, as it says, and it gives the customer the ability to control routing in a way that I can affect my inbound traffic flows. Normally I would use something like what? I would use AS path prepending out, or I would set the multi-exit discriminator value out, but there's nothing that actually says that the remote AS can't override that particular policy when they're making an implementation or when they're implementing their own internal policies, because those are optional attributes. Weight and local preference also rank higher in the overall decision process than ASPath or MED. Now, specifically what this RFC says is that the providers need to stage some sort of configuration so they can use a signaling policy like this to influence the decision. So let's see here. I think it's listed in here actually, the signaling policy. Let me find it here. Yeah, so like right here. So I might say, for example, actually it says here, MCI currently makes use of the BGP local preference attribute quite a bit. And these are the local preference values that they specify. Customer routes have a local preference of 100. Backup routes have a local preference of 90, which makes sense because the higher local preference is preferred. Other ISP routes 80, and then and so on. All right. But what we're saying is, you know what? Let's go ahead and set up a policy. In this case, MCI's AS number is 3561. And we're saying, let's go ahead and create a policy that says, if I receive a community tag of 3561:70 on those routes from the customer, I'm going to set my local preference for those routes internally in my routing decision, my routing policy. I'm going to map those over to local preference of 70, 80 goes to 80, 90 goes to 90, and so on. All right? So what we're basically saying is if your AS is 3561 and I signal you with that community, we're going to make that particular change. And this is something that we do, something that we agree upon when we sign some sort of peering agreement with our service provider. Bgp Pairing Agreement is basically a legally binding document that says, hey, when I peer with you with BGP, these are the attributes that I'm going to exchange. These are the routes that I'm going to accept from you. These are the, whatever the policy is, right? It could be, something like this where we're using community strings or community values as some sort of tag to be able to affect policy, right? So what we call this is community signaling. And the policy, the BGP Pairing Agreement, should identify what type of community signaling that particular service provider is going to support. If I go out to Google here and I do a quick Google search for, say, RIPE community signaling, I should be able to find a document that defines, I didn't look this up ahead of time, so I may not be able to find it right away, but let me see if we can find it here. All right, let's get rid of that. Let's see. So I couldn't find it on the RIPE site, but I did find one as an example for Cogent Communications. And a lot of vendors will actually publish this, this information, and it'll be part of kind of their standard BGP peering policy, which you can actually get from them, and you can identify how you should be tagging these BGP routes with their community string, all right? Essentially, this is the types of community signaling they're going to support. There should be something documented with RIPE. RIPE is one of those one of the 5 regional internet registries that allow us to define BGP peering policies in general. There's an AT&T one. I think AT&T is like 7018 or whatever. But this is the Cogent one, and it's basically saying, and they're ASN 174, they're saying that all customer routes are announced to Cogent will have a local preference of 130. Okay, and that's our standard local preference. A customer can control the local preference of their announcements by using community strings that are passed to Cogent in the BGP session, and these are the community strings that we allow. If you set the community string to 174.10, that means that you're going to get a local preference of 10. So that's basically least preferred. Remember, the default local preference is 100, and the higher the number, the more preferred the path. And I can say, okay, if I set it to 70, that's below other peers. If I set it to 120, that's below the customer default. If I set it to 125, just another level below the customer default. If I set it to 135, that's above, and so on. So I can essentially influence how Cogent decides to route to me, either through individual peers or based on individual prefixes, by setting these community strings before I advertise those routes out. And the great thing about this particular property, this particular policy enforcement, is that it is a transitive enforcement policy. So it can we can do this and apply this in a multi-hop environment. So it can go from one AS to another. So we actually have the capability of not only influencing how the direct neighboring AS routes back to me, but I can also influence other autonomous systems down the line. And normally I would not be able to do that, right? Because I would only be able to control essentially what I'm sending out, of course, but also what my neighboring AS is going to be able to do when they come into me, maybe by doing some MED or AS path prepending. All right. So basically, they're saying that based on how you signal me, the communities that I'm going, how you signal the communities to me, I'm going to adjust my local preference either up or down, which will eventually affect or ultimately affect how I decide to route over to you. I mean, this is great, right? Because this allows the customer to influence how the provider routes to the customer without the customer itself having to be involved in defining the actual policy. This is what we call a pre-staged policy, where we've already staged the policy and then we're able to identify what's going to happen with that policy. There are other applications to this as well, and we'll get into some of that maybe a little bit later on, but when we get into the MPLS VPN discussion. But for the most part, we're just going to look at this as a basic tag that we can use to influence path selection coming into our domain, all right, into our autonomous system. So we are actually talking about a concept of pre-staging an inbound policy to match on predefined communities, which allows us to set the local preference or potentially set other attributes. Local preference happens to be one of those most common attributes that we see, right? And we see no export is another option here, 174.990, do not send routes to my BGP customers or peers. 980, do not send routes outside of 174 in the European region. 970, do not export to North America, and so on. So there's lots and lots of different community strings that gives you the idea or gives you the ability to control policy. See, here's a prepending community policy that says we're going to do AS path prepending. So I'm actually instructing the service provider based on their pre-staged policy. If I mark my routes with 3003, I'm saying, all right, if you're going to advertise those routes to anybody else, go ahead and prepend those routes 3 times with 174 and so on. So every major service provider is going to have these different community strings that are basically used as tags to allow us to identify what's going to happen with that particular policy. All right, it's a pretty interesting concept. And I encourage you, if you guys are working with various service providers in your own businesses, that you take a look at what those policies are, because like I said, AT&T, L3, Deutsche Telekom, all these providers are going to have these community attribute policies, these pre-staged policies. So the result is that the outbound community signaling affects the outbound path on the other side, right? That's kind of opposite of what we're typically used to doing, right? Because typically an inbound policy affects outbound flow, and an outbound policy affects inbound flow. In this case, we have an outbound community that we're signaling, which is going to affect the outbound path selection from the service provider side. So by using these community numbers, which are basically just tags, I can control how the internet routes back to me without really having to do AS path prepending or setting MED values. And again, these are things that I would not be able to guarantee. All right. Also keep in mind, even though I can influence local preference is a non-transitive attribute. So it's not going to get passed down the line to other eBGP peers. But the community attribute is a transitive attribute. And it can be passed down to other eBGP peers, which means we can kind of have a common policy. Now, I'm not going to suggest that Cogent's pre-staged peering policy is going to be the same as AT&T's pre-staged peering policy. They could be completely different, all right? But what we can do is I can look at what those policies might be and actually show you guys this a little bit later on, but we can actually apply multiple communities to a particular route, and then each partner, each major provider can match on one of those community values. So I don't actually have to set the community value to a single value. I can append multiple community strings to a prefix or to a neighbor relationship, and then maybe it's a community string that matches a Cogent policy, and it's another community string that matches an AT&T policy. As long as I'm aware of what those policies are, I can get pretty creative in how I can manipulate the path selection process. I can't signal you directly to say you should prefer this as a reverse path to me, but I can use your pre-staged policy. So when I do my BGP peering, I know what your well-known policy is. I'm going to have a route map if I'm using, say, iOS, or some sort of routing policy language if I'm using iOS XR, and I'm going to apply that as an inbound policy to that neighbor that says, based on matching these predefined community numbers, and based on finding these values, I'm going to set the local preference. I'm talking from the service provider's side, or from the service provider's perspective. I'm going to go ahead and set the local preference or any other attribute, and then I'm going to then pass that out to my peers. And the end result is that setting a community outbound from my side to you affects your outbound policy back to me, right? So outbound policies affecting your outbound policy is doing the reverse signaling, right? So that you can set your inbound policy to affect your outbound traffic. It's kind of like an instruction. I mean, we're not breaking that rule that says inbound policies affect outbound traffic, but I'm influencing that by setting an outbound policy. All right, so we're going to do this as an example between AS100 and AS51. And we're going to, if you look at the diagram here, I'm going to create a prefix on router 4. We're going to go ahead and send that prefix into the iBGP domain, and then that will in turn get reflected or re-advertised out of the domain through the eBGP peers. We're going to set that, I'm going to show you a couple of different ways that we can set these community values. And then we're going to actually set a policy on router 5 and possibly router 3. I think we might just do router 5, but I'm going to set a policy on router 5 to pass this community attribute. I'm not going to get into a whole scenario of actually doing some sort of load balancing scenario, or not load balancing, but manipulation between router 3 and router 5, because I don't think that's important. The most important aspect of this particular exercise tonight is that you understand that you have the capability of doing this. I think we've done enough lessons over the past month or so to where you can understand what the overall implication is of being able to implement this on a per prefix basis or a per neighbor basis to influence how traffic is going to come in and leave the network. All right, so I'm going to try and keep it pretty basic and give you guys an idea. All right, so let's go ahead and do this. If I have some additional time, I might do some additional configurations, but like I said, the main thing to understand here is how this information is configured. There's some caveats to doing these configurations that you have to be careful with because you can actually implement it incorrectly if you don't understand how these attributes are set and how they're matched and so on. Okay, so we're going to do this between AS100 and AS51. Normally, I would set the AS path prepending outbound on, say, router 5 or maybe even possibly router 4 to get router 7 to send traffic into AS100 either through router 3 or through router 5 or even over the backup link and so on. All right? But this is going to really depend on what they're doing. So if they're setting a local preference on their side, because AS path falls below that in the order of operations for the BGP selection process, me setting the AS path length might not even affect the policy. All right? And it's kind of an unwritten, well, it's more written, I guess, idea that local preference is really the primary attribute that we use to make outbound routing decisions when we have multi-home connections. Because weight is local to the router, plus it's a Cisco proprietary attribute, so it can't really help us. And local preference is really that first well-known optional attribute that everybody's going to understand. All right. So we need to match on community. We need to match on the community attributes. We're going to go ahead and use communities to trigger a policy. So we know that we're going to go ahead and have to stage R5 and R7 for that particular policy. All right, we need to match on the community attributes. We need to specify what the values are going to be mapped to. In this case, I'm going to go ahead and use 100:90. And if I set, let me make a note on the screen here so we have this as part of our configuration here. So I'm going to have a 100:90. That should match to a local preference of 90. And I'm going to have a 100:110, which should result in a local preference of 110. All right. That's going to be something that I'm going to set on router 5. I'm going to explain why I'm setting it on router 5 to start with. I could actually technically set this on any of the routers in that domain. And usually you would want to try and set this community attribute on the router that's originating the NLRI for that particular prefix. But we're going to do something different here because I want to make sure that I'm showing you some of these caveats that you have to be concerned with. Now, the whole application of this policy means that we assume that all of the routers are exchanging community attributes when they do their peerings. And in fact, with Cisco IOS, that is not the default behavior. They don't exchange community information with each other. All right. Now, in general practice, this is something that we would normally enable on all of our BGP peers, just as a standard policy. And it's not something we've looked at to this point because we haven't talked about this concept, but we would want to do this on most of our routers. So if I go into my router 5 or router 4, any one of the routers, and I do a show run section BGP, we can see we've got a standard BGP configuration. Our router 4 is still our route reflector in this particular environment. And we've got iBGP peering relationships and so on, redistributing our loopbacks into BGP and so on. So basic standard configuration. All right. Now, for all the boxes in our topology, that includes our iBGP and our eBGP peers, we want to set it up so that we can exchange these community attributes. And the way that we do this is we specify our neighbor and we execute the send community string. So if I look at my topology diagram, I've got R2, R1, and R3, and R5. R2, R1, R3, and R5 are neighbors with router 4. So I'm going to do those routers first. So we got R2, R1, R3, and R5. And we're going to go into router BGP. That's good. Config T, router BGP 100, neighbor 4.4.4.4, send community. This is the command that's going to initiate that concept of sending the community attribute along with the routing information. All right, of course it would help if I spelled it right. Let's try that again. Neighbor 4.4.4.4 send dash community. I'll just abbreviate it. Let's do that. All right. So that should be in there for R3, yep, for R5, and for R2. Okay? So in R4, we need to do this, of course, for each of the peers. Show run pipe section BGP. And we also want to do this for our external peers on R1 and R1 and R5 and R3. So let's go config T, router BGP 100, neighbor 1.1.1.1, send community, and we're going to do this for 2.2.2.2, and we're going to do this for 3.3.3.3, and we'll do this for 5.5.5.5. All right. And then we want to go into R3. And we want to do this for our eBGP peers as well. So neighbor send community. And finally on router number 5. Oh, we have to do router 1 as well. Do show run pipe section BGP. We got there. So let's do neighbor and router 1. Now, the do show run pipe section BGP. The thing to keep in mind here is that this is an asymmetric process, right? Just because I'm sending a community doesn't mean that I need to receive a community unless I'm using the community to affect policy change. So we're sending this really to the peers just to make sure that this attribute can be propagated across the iBGP domain. But on router 7 and router 8, which are my external peers, I don't necessarily need to send a community back into router 5, router 1, and router 7. All right. Just because I expect to send it out doesn't mean I expect to get it back. The only reason that would really matter in our case is if we were a transit AS and we were trying to use our Autonomous System 100 as a transit AS to route to other autonomous systems or other destinations on the internet. Okay? All right. So that's the first step. And again, this is most likely something that you would do anyway. The reason you need to do this everywhere is because if I send communities to you and I give you the attribute, but you don't send the attribute to your neighbor, whether it's an iBGP neighbor or an eBGP neighbor, you're going to end up stripping that value from the BGP update. Okay? And then whoever is downstream or upstream is not going to be able to make policy decisions based on that because they're not going to see that information. All right? Now, what I'm going to show you is when the communities are transitive and the peer is not stripping that information, that signal, if you will, we can influence the path selection even from an AS that's not directly connected. If I have a chance to show you that, I will. I think you're going to understand that regardless of where the policy is applied, as long as I can see that attribute, I can make a policy decision based on that attribute. All right, so this is an example where you can actually do this on the internet to indirectly signal a provider that you're not peering with. All right, technically I don't send them back in the other direction. It's not like a negotiated policy. It's not like a negotiated capability between the peers. So just because I'm sending community attributes doesn't mean I expect to receive them. All right. So before we can go ahead and establish our policy, the first thing that we need to do is start signaling that community string. So let's go into router 4 and let's originate a new prefix. Let's do a show IP BGP and let's do a Let me see. Well, I guess I can just do a show IP BGP. So in this case, in router 4's case, why am I not getting any prefixes? Should be getting other prefixes. Idle. Why show IP BGP summer? Let's do show run pipe section BGP. Let's do a clear IP BGP star. I should be getting IP protocols. EIGRP 100. We're not applying any filters. Show IP route. Oh, never mind. I forgot to turn on all my interfaces. Hold on, let me pause the video here. I forgot I'm using iOS V in this case. I've got to turn on all my interfaces. Interface gig 00, no shut. Interface gig 01, no shut. Interface gig 02, no shut. And interface gig 03, no shut. And right. Send that out. All right. Loopbacks are up automatically. So that's why we could see the loopback in our BGP database, but we couldn't see everything else. So anyway, let's get back on track here. So as I'm waiting for this to converge, if I do a show IP BGP, I should see I've got adjacencies. One hasn't quite come up yet. Let me go check one. Let's see. Those interfaces didn't come up. All right, let's go back to router 4. There we go. All right, so now if I do a show IP BGP, what I'm trying to do is just give you an idea that we're not originating this prefix presently. And if you look at local preference values, you can see all the local preference values are 100. All right, so I'm going to create another loopback, interface loopback 44. And I'll give that an IP address of 44, 44, 44, 44 with a /32 mask. And I'm going to go into my router BGP 100. Now, in this particular case, I am going to send this prefix into BGP, but we're going to set the community right on the prefix as we originate the route. All right, and this is one way of doing it. There are other ways that you can actually manipulate the community value, but I'm going to go ahead and create a route map called loop. And I am going to set the community. Why is it just not typing it correctly? Set the community to 100:44. All right. So there are other ways that will come in later in more detail. There are also other set options. So for example, if I did set community question mark, I have other options like graceful shutdown and internet and local AS. I don't know how much we'll get into these in detail later on, but I will highlight some of these functions later on when we get into the MPLS, Layer 3 MPLS VPN discussion. So under the BGP process, we simply now want to originate the NLRI information with the network statement, but we're going to apply the attribute change right at that point. So I'm going to go into router BGP 100, and I'm going to say network 44, 44, 44, 44 mask 255, 255, 255, 255 route map loop. So we're actually applying this attribute directly on the prefix. All right, if I do a show IP BGP, I should see, show IP interface brief, up, 44, 44, 44. Let me see if we're seeing this. It should certainly be in my local database, but let me go check router 5. Did I make a mistake on the route map? Show run pipe section BGP pipe route map. Network 44, 44, 44, 44. Route map loop. Oh, I already had a route map called loop. Dang it. Which means that I messed up my redistribution. Well, it actually means that I should be setting the community for 4.4.4.4 as well. Let's try that again. Let me go ahead and create a route map called loop -C, and we're going to set the community. Now you'll notice that the community is actually listed in decimal value. I'll show you how to change that later on. It's a global config command that we'll take a look at, and we'll set the community to 100:44, and do show run pipe section BGP. Router BGP 100, and we're going to set this to loop-C. All right, so now 44, 44, 44 is going in there. If I do a show IP route, 44, 44, 44, 44 / 32, sorry, I need to do a show IP BGP, 44, 44, 44, 44 / 32. I can see that in this case, the community attribute is set. Now I'll show you later on how we can change this to the default value, or the rest, or the modern syntax rather than the decimal value. Sorry, I got distracted. Ken asked if I could show the whole configuration. So because I kind of messed that up a little bit, let me show you what we're doing here. So what I did is the first step that I did is I created a loopback interface 44, okay? So I'm just originating a prefix into the domain, all right? The second thing that I did is I created a route map called loop-C, and that route map says, let's go ahead and just set the community. We're not matching anything because we're not actually applying this route map. We're applying this route map directly to the NLRI reachability, the network statement in BGP. And then if you look at the network statement under BGP, I referenced that route map that set the community to 100:44. All right? Does that help, Ken? Now, in previous examples, we're applying the attribute changes to neighbor relationships. For inbound neighbor relationships or for outbound neighbor relationships. But in this case, I'm applying it directly to the NLRI origination. It should be successful though, because I'm sending communities to all my peers. So if I go to router 5 as an example, I should actually see for show IP BGP 44444444/32, I should see that same community information listed here. And sure enough, we see that community information listed there. All right. There's a community value. It was signaled specifically as 100:44. Here we see it in decimal format, which is the old format. But we want to see it in dot notation. We just have to simply change it. So we're looking at decimal, but maybe we want to see the 4-byte field. We can actually change this in global config. Let me do that on all the routers in this case. All right, we're good there. And I'm going to do a config T, and I'm going to do a IP BGP community new dash format. All right. And that should change all my routers to look at these at any of the BGP numbers in the new format. So if I go ahead and review my output again here, I should see the 100:44. Okay. Do I see it on router 7? I don't know. Let's take a look. Show IP BGP 44444444/32. And sure enough, we do see it here. We're getting the route from router 8, and we're getting the route from router 3, and we're getting it from router 5. Those are the 3 options that we have. In router 5, we have 2 different links that we're receiving the route from as well. So my point is that this, because I've set the send community configuration on all the routers, this community attribute is now being propagated to all of the routers in BGP, including eBGP pairing relationships as well as iBGP pairing relationships, which is good because now I can affect policy on router 7 based on a pre-staged configuration, which we obviously didn't have in this case, based on a pre-staged configuration on router 7 that allows me to say, if I see a route with this community attribute, I'm going to go ahead and do this, whatever that policy is. So that's a very simple concept, right? Create a route map, match on the community, set a value, okay? The wonderful thing about this, though, is that it will propagate from AS to AS to AS to AS, as long as all of those routers understand that they're sending community information, which most global internet providers are going to do. All right? Now, as of yet, we actually haven't configured any policy to force the attribute changes, so the community is not really doing anything. It's just basically like an administrative tag on the route. The thing with the community string is that where a lot of the extensibility, if you will, comes in is what is used a lot in, say, like a layer 3 MPLS VPN, where we use extended community attributes to encode things like what is the OSPF type of route that it was originated from, what are the EIGRP vector metrics, what is the route target value, and so on. It's a really, really flexible field, and you can pretty much do whatever you want with it by writing your own extension to BGP to manipulate or to utilize this value. So next, let's go ahead and prep the actual policy on router 7. All right, now I'm going to do something a little bit different on router 7. It might look a little strange initially, but trust me, we're going to get to where we need to go. If the routes come in with certain community values, we are going to change the local preference to whatever we want. So let's assume that we're doing this on routes from router 5, okay? Specifically over the primary link on router 5. And like I said, I'm not going to go and do it on router 3 and then also do it on the backup link on router 5. You can extrapolate how this could be applied to multiple peering relationships to essentially set the local preference to say, hey, I want to use, let's say, for example, in this case, I want to use router 3 as the primary path to get to 44, but I want to use this link here as the secondary path, and I want to use this link as the tertiary path. We would basically have a policy that says set the local preference based on that tag that we applied, set the local preference to different values for each of these peers. But we don't need to do that because I think you guys understand how that could be done just by simply duplicating what I'm about to show you for different peering relationships. The main thing to take away from this is that you understand how we can match these community values, and then based on those match conditions, we can set a particular preference. So let's create a route map. Route map from R5. And we're going to say match community. And let's say 100:90. I know we didn't set that community value, but trust me, we're going to get there. We're going to say set the local preference. And we're going to say set that local preference in this case to 90. All right, then we'll do another route map from R5 permit 20. And we're going to say match community 100:110. And we're going to set that local preference to 110. And again, how many different match statements you have or how many different set statements you have depends on how much flexibility you want to have for manipulating individual prefixes or whatever, individual peers or whatever. Because this could be kind of a global policy that we apply to both links in our topology. All right? And then let's kind of do our catch-all permit statement, which is just to permit everything else. Okay? Now, if I do a show IP BGP summary, I want to go ahead and apply this over this 57 link. All right? I want to apply this policy over the 57 link. So I'm going to go into router BGP 51, neighbor 57.5, right? We're applying this over this peering relationship. And I'm going to say route map from R5 in. Okay? Now let's assume that from R5 we're actually signaling this. So we're not signaling this yet, right? The only signaling that's being set is on router 4 for the 44 prefix, which was 100.44, 100:44. So now we need to go to R5 and we have to actually set this value. All right? So let's go ahead and create another route map on router 5, config T, route map to R7, and let's set the community to 100:110. Now again, we could match, prefix lists that match specific routes. We could, match AS path. We can match anything that we decide that we're going to match on, we could apply, right? Again, there's 100 different examples I could demonstrate that could show us how we could manipulate these values. So the point here is that we want to see how the attributes are passed and whatnot, but you can extrapolate everything else that you've learned about manipulating attributes within BGP or matching on certain conditions, regular expressions or prefix lists or access lists to make decisions based on routing, okay? So in this case, we're basically just going to say anything that comes from R5. All prefixes that come from R5, we're going to go ahead and set the community to 100:110. All right? So in this case, we're just not referencing a specific route. So under the process, I'm going to say under router BGP 100, I'm going to say neighbor, well, let me do this real quick. Do show IP BGP summary, pipe include 57. So I'm going to say neighbor, come on, 57.7. And again, we'll just apply this route map out to _R7 out. Okay? I need to clear out my do clear IP BGP star out. And did I do it on the other side? Do clear IP BGP star in. All right. Now from router 7, let's go ahead and do a show IP BGP. But specifically what I want to do is I want to do a show IP BGP for 44, 44, 44, 44/32. And here's the reason why I want to show you guys this. Because we can see from this output here that from over the 78 link, we still see the community of 144 and 144 here from the over the 37 link. And it looks like what's happening in this case, because remember we set it to 144. I should have another one here though. Why isn't it there? I should see it over 57 as well. I'm not seeing the community applied there. Let me make sure I did this correctly on router 5. Do show IP. Let's do this. Do show IP BGP 44, 44, 44, 44/32. So we're getting it as 144 in from router 4. Makes sense. Do show run pipe section route map BGP. No router. Let me make sure I didn't fat finger something here. So I've got a neighbor relationship for 57.7 route map 2R7 out. And I look at route map 2R7. I forgot to put in the second route map statement. We're setting the community to 100.110. Let me see, do I have anything else going to 57? I don't have anything else going to 57, but I'm not doing a send community. That's what I missed there. Notice I don't have my send community. I need that in there, which is why I'm not getting that value. Do clear IP BGP star out. So now I should see, there we go. All right, so the reason why I did it this way is kind of convoluted because I'm setting the community on router 4 and then I'm basically setting it again on router 5 for all the prefixes on that link. And you can see that actually 100.110 is being applied. All right, whereas on the other links, because we didn't have a policy applied there, router 4 is originating that 44 route with a 100:44. It's just being sent out those links with 100:44. So I could actually say, okay, based on the inbound policy or based on the inbound attribute, I could have some sort of outbound policy that says we're going to do this, this, or this, right? Here's the problem though. The community value was overwritten. All right, R4 was doing the origination. It was setting the community to 144, but R5 said to go ahead and set the community to 100.110. It removed the old value and it replaced it with the other one. So that community value is non-additive. In most real case scenarios, you want to set the community value as additive, because that means that anybody down the line can look for any community value in the string and make a policy decision based on that community value. So maybe 144 was something that Cogent would recognize, but 100.110 was something that AT&T would recognize. And this is how you can influence how these other providers make policy decisions based on that community attribute. Okay? So what we need to do is we need to change our route map to set the community as additive. All right? And so let's go ahead and do that. Let's go back to router 5. Okay, do show run pipe section route map. And I'm going to go into route map. I got all these different route maps going on here. I'm going to go into route map R7, and I'm going to set the community here, but I'm going to set it as additive. All right, do clear IP BGP star out. So now when I go to router 7 and I look for that prefix, I can actually see both community values listed in the community attribute. So now Cogent can make a decision based on 144. AT&T might not recognize 100, 110, but guess what? They may not recognize 144, but it may recognize 100, 110, and we can now make a policy decision based on that particular attribute. All right. Now, if I go to, so we're seeing this now in router 7. The question is, local preference still hasn't been modified here. So the policy did not get applied, but we haven't created that policy yet, right? Right now, we're just making sure that the route map was added. Actually, let me do a quick show run on this. Do show run. I thought we did actually set that. Show run section route map. Okay, we did right here. From R5, if we see a community value of 100, 110, and that includes any value within that whole string, we're going to set the local preference to 110. But it didn't do that, right? Because I see the local preference is still 100 in this particular case. All right, and I did that on purpose because I wanted to demonstrate kind of another bug in the parser. And if you end up having to do something like this on the CCIE, this is something to definitely be concerned with. What we're actually matching on in this case is not a community string value, but it's a literal string set called 100, 110. So if I go into the route map, let's go into here, and I say match community, question mark, we actually are trying to match something called a community list. A community list. So even though I put the number in, I'm not actually matching the literal string, I'm matching a list called 100, 110. All right? And that's you know, it doesn't tell me, hey, you don't have a string called a list called 100, 110, so it's not going to do anything. And that's something that you could run into. So we actually need to call this community attribute from another step that we didn't configure. In most cases, you're going to want to match the community list based on the community name. So we do have to do one more step in order to have this match. Otherwise, this configuration just simply doesn't work. All right? And that's means that we have to configure a community list. All right? So let's do that. We're going to do this in global configuration mode. We're not going to have to change our route map because we're going to actually name the list based on the string that we put. IP community list standard 100, 110, and we're going to permit 100, 110. All right, now we could do the other one as well if we wanted to. We're not really matching anything there, but if we want to make our configuration consistent, we would create that. Now if I do a show IP BGP for 44, 44, 44, 44/32, I should see now that the local preference was applied. Okay? So the local preference was applied, and by the way, that local preference is then going to get propagated to the other routers within my autonomous system, which is going to influence my overall path selection for 44, 44, 44, 44. If I do a trace route to 44, 44, 44, 44 from my loopback 0, we can see that we're using the 75 link. Why are we using the 75 link? Because of weight. We got this weight applied here. Remember, weight takes precedence over local preference. So let's get rid of that. we got some remnants from our previous configuration. Do show run section BGP. And we need to get rid of this. So router BGP 51, and let's get rid of that. I don't think I need to reset. Let me do a show run or show IP. Well, let's just do our trace route. Nope, I do have to do clear IP BGP star in. There we go. All right. So again, this is, you know, it could be something that you see on the test, on the lab, where somebody, you know, they throw in that wait configuration and it's not doing what you're expected it to do, but now because you understand the BGP selection process, you understand that wait would affect that route. All right. So I guess that's kind of it. All right, we see, you know, how the policy's applied. We can see the local preference is higher. And then I guess by signaling the policy outbound, like I said, if the provider is pre-staged, we can affect the traffic flow. And we could also even maybe set a policy on R8 as well, because if I go over to R8, actually I don't believe I'm going to see this in this case, show IP BGP. Well, I'll see it from R1, but I won't see it from R7. So we're seeing it from R1, 144. We're not seeing it from R7 because we didn't do the send community on R7 to R8. But again, we can see that well, let me just do that on R7. Let me just do that on R7, just so you can see that this is a transitive property. It is something that propagates to beyond the initial AS, peering AS. Show run section BGP. And let's do router BGP 51. And we're going to do neighbor. Oops. Send community. All right, clear IP BGP star out. I'm going to go back to router 5, or excuse me, router 8. And now I should see that both from router 7 and router 8. So, you know, this is the wonderful thing about this community list. Because, like I said, this could be continued, and generally this is the case. Most public domain service providers or internet-based service providers are going to be sending this attribute. We can influence pass selections multiple ASs away based on understanding what their peering policy is and how they're going to manipulate routing or manipulate their local attributes based on that community attribute. All right. You guys have any questions? Okay. Well, hopefully you learned some good stuff tonight. I'm going to upload the video right now so that you can review it. We're not going to have a lesson tomorrow, but we'll most likely have a lesson on, well, we are going to have a lesson on Thursday. Will this be on the test, Chris says? Let's assume for the written exam, certainly. You're going to have to understand how the community attribute can be used to manipulate pass selection. I doubt that this is something you're going to have to configure on the lab. All right, I doubt it's something, certainly community attributes will be covered on the lab, but probably in more of a traditional sense. But you know, you never know. I didn't see it on my labs. I took that test a few times. I never saw it on my labs, but again, we don't know for sure. But I would, if you're a little bit lost, I would review the video again. And I will actually upload, I'm going to export this topology. In fact, let me go ahead and do that right now. And let's do an end and a right. And I will export this topology so that you can go ahead and review it as part of the review. Okay. All right, guys. Well, hope you enjoyed tonight's lesson. I guess we'll see you guys in the next lesson.
Thanks, Scott.
Yep. Bye.